Hello everybody, and in this video we're going to apply some of the concepts that we saw in the previous lecture on for loop, and we have excuse me we have the first example on the for loop right here in front of you, where we are using an unsigned counter variable where starting with a value of 1, we're counting up till 10, and we're printing every value at each iteration of the loop. So let's quickly run this. There you go. It's basically prints values from 1 to 10. Another thing that you could do with this is you don't have to declare it outside the loop. You can actually declare this within the loop as well. So you could write unsigned int counter, and that should also work, and you see it does the same thing. In addition to this, one of the other things that you could do is you see that you're doing post increment here. You could do pre increment, but it should not make a difference. So let's quickly see, and we've discussed this in the lecture. To increment a loop, to increment a for loop, whether you use a post increment or a pre increment, it should not make a difference. And you see it again prints numbers from 1 to 10, and there is no difference in the output. Okay. Also, one of the other things we discussed was that you do not have to increment by just 1. You can actually increment the value by some other number. So let's increment our counter by 2. Say we want to print all even numbers from 0 to 10, then what we can do is we can start from 0 and go up to 10, and every time we can increment by 2. So let's try this example, and you see you get values 0, 2, 4, 6, 8 and 10, which are all even integers from 0 to 10. You could also maybe change this to more than 10. Let's say you could print all numbers from 0 to 100, and let's say you want to give an increment of 10. So what it will do is it will print values like 0, 10, 20 and so on and so forth until it gets to 100, and you see that it prints a value of 100. Okay. Now if this value was only less than 100, then it would it would stop below 100. So 100 would not be printed. You would only see values up to 90, which you do, right? So this time around you do not see 100, you only see values up to 90. So that's also interesting. The next thing that I would like to show you is that you don't always have to go in ascending order. So you don't always have to increase values. You can go in the reverse direction. So you can start from 100 and you can go down to 0. So if you make this greater than equal to 0 and you start from 100, so you're starting from 100, and then you should be stopping when you go below 0, and let's see what it does. So now, because you're starting from 100 and you're going down, you need to give a decrement instead of an increment. So we're going to use minus 10 or minus equal to 10. Now let's see what happens. Something unexpected happened, right? We were not expecting this. Well, we obviously have done something wrong. So let's see what that is. Right. Now the reason why you're getting something wrong, or why your loop is not doing what you wanted to do, is this unsigned int. Now because this is an unsigned int, you actually should not be getting any negative values. But what happens is, once you actually get to 0 and then you subtract 10, if this was a signed, if this was a normal integer, you would have gone below 0, so you would have gone into the negative direction. But in this case, what happens is minus 10 actually gives you the largest value of an unsigned integer. So if you want this to work, you have to use just a normal integer, not an unsigned integer. Now you're seeing some sort of a hint here. So you can actually see that you see this, you should be able to see this green squiggly line below the for loop. So this is giving you a hint, and once you actually go there and you hover over it, it actually gives you a hint. It says ill-defined for loop, unsigned int values always range from 0 to some large value. Now this is a warning kind of that the compiler is giving you. Now if you get rid of this unsigned integer, this probably should disappear. It doesn't disappear right now, but let's run this, and now you see it's working as expected. So you go from 100, 90, 80 down to 0. So this makes it work. A couple of other examples that you could try. You could maybe do some of the examples in the book. So those you can do yourself. I'm going to leave those for you to do on your own. The next example that I want you to do is the one where we were actually summing up values. So we were, let's say, using an integer, unsigned integer sum, which we were initializing to 0. And what we want to do in this example is to sum the values of numbers, all even numbers from 0 to 100. So we can modify this example slightly to make it work in this case. So in this case, what we're doing is we have an unsigned int sum, and then our loop is going from 0 to 100 in steps of 2. Now inside the loop, what we want to do is we want to accumulate the values of the loop variable, which in this case is counter. So we're just adding the values of the loop variable counter, and we're putting those inside a number, a variable called sum. And then what we can write is sum of all even numbers between 0 and 100 is %d, and we want to print out sum. So this should give us the sum of all even numbers between 0 and 100. So let's see what that is. And so the value is 2550. Okay. One thing that you can actually do within this program is you can also, as I said, that you can actually add multiple statements in the increment part. So this statement that you have over here, which basically is sum is equal to sum plus counter, you can actually cut this and put it inside the increment part of the loop. And if you remember from the lecture, we said that you can put multiple statements in there if you separate them with commas. So we've separated those with commas. Now inside the loop body, we're leaving a semicolon because that just tells the compiler that there's nothing being done inside the body of the loop, so that's just going to stay there. And this program, if we run it, should give us the same exact output, and you see that you get the same value that you got last time. You can also add another variable. You could also add the initialization of the sum to 0 inside the initialization part. So if you write something like sum is equal to 0 and then you separate this with a comma, then it should work. Now notice that you actually get these red squiggly lines, and that is a hint that you should expect an error, and you will get an error if you try to run this. You will get a compiler error. You will this is not allowed. Now why is this happening? Well, if you're going to initialize multiple variables inside the initialization variable, initialization part of the loop, you cannot declare both of them over here. So what you can do is, if you actually declare counter over here, so if you declare counter outside of this, then this should go away. So now this should work. So let's see if it does. And yes, it does. So this is just something that you need to remember. So you've learned now how to kind of write multiple statements inside the initialization part and the increment part of the loop as well. So this is something which can be useful at times. So another handy trick. Right, so the next example that I want to show you is the profit calculation example that we saw in class. So we're looking at starting off with a principal investment of $1,000. We have an interest rate of 5%, and then within the loop we are looping over years. So we are showing the profit every year over a period of 10 years, and then the amount that we will have in our account at the end of each year is going to be calculated using this formula, which is over here. Now for this formula we need to use the power function, which is part of the maths.h header file. So we need to include that at the top of our program, because if we don't, then the program won't recognize this. So let's quickly look at this example and see if it works. And you see that it does. You actually get your profit at the first year, and then you see it up till 10 years. So this is an interesting example. Now one more thing that I want to do is, let's say I want to print the value of the year outside the loop. So if I try to print it out here, what you actually see is you get an error. And what is that compiler error? Where it says it does not recognize year. Year is unidentified here. and that's kind of funny because here you're kind of using the year inside the loop and it seems to work all right, but over here magically your program does not know what it is. And why is that? Well, that's because the variable year is not visible to the rest of your program outside of the for loop. Because you're declaring it inside the for loop, what C does is that it deletes the variables that are declared inside the for loop. So another variable that is declared inside the for loop is the double variable. Now if you try to print, the double amount variable, if you try to print the amount here, and the amount is double, so we print that as a float, and what happens is, well, it doesn't recognize amount as well, and the reason is amount is also not visible outside the body of the for loop. If we used another variable, let's just say principal or rate, they would be visible here. Why? Because even though they are being used inside the loop, the body of the loop, they are declared outside the loop, and so they are visible here. Now why are these variables not visible outside the loop body? Well, C does this in order to save space or save memory. So the variables that it feels are not needed outside a certain body or part of a program, it just goes ahead and deletes them. So that's why you don't see it here. Now if you wanted to see these variables over here, one workaround to this would be to actually declare them outside the loop. So if I declare year outside the loop over here, and then I kind of write year here, you actually see that it does appear now, right? So it is being recognized because now I am declaring it here. So this is something which is useful to remember. So let's quickly run the program, and now you see that year actually is visible here. Sorry, this is not a float, so this has to be an unsigned, so it's U. Now it should be visible, and so you see year is 11, which makes sense because at the end of the loop the year variable actually has a value of 11. One more thing that I want to talk about in this program is, if you want it to look a little bit prettier, what you can do is you can put some dots inside this program. So if I maybe print 21 spaces here, and then 21 dashes here, and then maybe 21 dashes at the end of the loop, it will actually make my output look more like a table. So let's quickly do that, and you see that yes, actually this is 25 dashes because we have 4 characters for the first string, which is here, and then 21 characters for the second string, which is this part here. So we have 25 of these things here. This is what you see. Another thing that you could do is, by default you notice that the text in both these areas is actually is right justified, so it is moved to the right side. You can make it left justified by writing %-4s and %-21s. Similarly here, %-21.2. Now this is 21.2 because you're printing a double variable in a space for 21 characters with double precision, right? But if you put minus 21.2f or you put minus 4, what that means is it, instead of justifying it to the right, it justifies it to the left. Let's quickly run this. And now you see that this actually, instead of being in the right corner, your text now is kind of back towards the left corner, so it starts over here. I personally feel that when it was right justified, it looked better, so it's probably better not to left justify, but I just wanted to show you that left justification is also possible, so you can use that if you want to. So now you can see it kind of comes back again, and this is much nicer to work with, so you can play around with this as well, and that's that. So thank you.